Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and this is a good day to do our last video of Euclidean geometry for the exam preparation, as we are going through last year's matric final paper written by the Department of Basic Education Schools. In other words, all the normal public schools. Now, I don't mean normal in a bad way or in any other way. It's just a mere slip of the tongue. All our public school students. This video is a fantastic video to show you how we can mix grade 11 and grade 12 geometry, Euclidean geometry, into one amazing, beautiful mess. I love to say it's a mess. But go and try the sum yourself. Make sure that you can do it. If you are still struggling a bit, that's okay. I'm going to work through it. But first, try it yourself. So as we look at the sum, I will hope that you realize that before I even look at any of the questions, I'm going to mine, I'm going to delve, I'm going to dig through the information as best as I can. So in the diagram, PK is a tangent to the circle at K. So I'm going to think about theorem 7, 8, and 9 because those are my circle theorems. First of all, I cannot use theorem 7 because I don't have a radius. I don't have a line from the center of the circle to that point K there. So therefore, I'm not going to use theorem 7. Theorem 8 requires two tangents. I don't have two tangents, not even two that looks like tangents. But even if it looked like one, I only have one tangent. Now theorem 9 I'm going to use, and why is that? Because remember 11.1, they asked me to actually prove theorem 9, so I know I'm going to use theorem 9. So first of all, if I've got my tangent P in K, I can first of all see that K1 and 2, if I go from bottom up, is the same as L1 and 2. If I move from the top down, so there, then K4 is equal to S1. Remember, I'm working in this triangle there, and there's my tangent. Sorry, let me just do my tangent there. There's my tangent. Okay. Please make sure you get this. Please make sure you see this, because if you don't, you've got to come to your teacher and ask them to sit with you, or to a friend who sit with you to see theorem 9. Okay? So theorem 9 I've extensively used. Next up, MN is parallel to SK. So the moment I read parallel lines, I go back to grade 8. My grade 8 always was a lot of fun. Okay? That's the worst pun of the day. First of all, corresponding angles, and F. So looking from the bottom up, can I kind of put it that way? If there and there, okay? Then also from there, going up that way. Easy to see if I use the different colors. So if I use the F's in that way, and also in this way, that was not nice. That one and that one. I've got the green ones that are equal. And I've got all of those pairs that are equal. So M1 and S2, S1 and M2 and 3, and N2 and 3, and K3 and 4. So as I indicated it on this, I've used the F. I'm not going to look at the corresponding, co-interior angles, simply because I don't have values. And co-interior angles add up to 180, so I kind of want values. But I'm not going to use the U. So I'm not going to use the U. But what about the N? Yes, the N. There I have alternate angles. So M2 and K2 are the same. So I've used the N. But don't forget about theorem 1 of metric work. So if I look at this triangle there, and I highlighted it in red for you, okay, that PM over MS is the same as PN over NK because I'm working in that triangle there. I'm going to erase that because I need to be clear that I've got another triangle there, where I can use that LS over SM is LT over TN. In that triangle, my lines are not going straight today. In that triangle there, that LS over SM is LT over TN. Okay? And therefore, I have also grade 12 work. So it's not just FU and N you need to think of with parallel lines, but also theorem 1 of grade 12. Okay, but now we've written so many things here that I kind of need to tone it down a bit for the first question. So I have erased, or just erased some of the things to make it easier for you to see. So the first question is, prove that K4 is angle NML, or M2 and 3. So what is the connection point between them? Well, K4 is the same as S1, and S1 is the same as NML. Ladies and gents, I knew I was going to use theorem 9 because they asked me to prove theorem 9. I love this. I just love it. So let's start by writing this down for the examiner. K4 is equal to S1 because of tan chord. S1 is equal to NML because of corresponding angles. But please remember your parallel lines. I get angry at my matrics when they don't remember that because they lose that mark then. Therefore, K4 is equal to NML. Again, don't forget about what we just did. We proved K4 is equal to M2 plus M3. In the next question, 11.2.1b, they ask me, prove that KLM is a cyclic quad. Now, I only have 3 ways of proving a cyclic quad. I can use theorem 4, theorem 5, or theorem 6. But look at what was asked in A. They asked me to prove K4 and NML. So by highlighting my quadrilateral that I want to use, I am going to see, but oh my goodness, for me to prove this is cyclic quad, I'm going to use theorem 6 because theorem 6 requires me to prove K4 as the same as NML. But I've got this. So I'm just going to write it down for them. KLMN is cyclic. Why? Because the exterior angle is equal to the interior opposite angle. Please remember, ladies and gents, if I can go back 2 slides quickly, it's only worth 1 mark. Because it is only worth 1 mark, I automatically think, oh, I've got to use the previous question. I've got to use what was done there. And if it was maybe 4 or 5 marks, I would have thought further. But because it's only 1 mark, I'm going to use what I already have. Let's now have a look at the next question. This is now where life becomes a tad more interesting. But remember what you have already just proven. I've just proven that Km or KLMN is a cyclic quad. Because I've proven this, I'm going to look at all the theorems that now actually work in a cyclic quad. Remember, you've got theorem 4, 5, and 6. I'm just drawing them roughly there. I didn't do the circles around them. If it helps you, maybe for me to draw circles around them. Okay, I'm just trying to do it roughly here. First of all, let's look at theorem 4. I love to just color in my diagonals of my cyclic quads because it then colors in the different bow ties or the different butterfly wings that I'm going to use. First of all, L1 is equal to M1 because I work in this shaded part there. Okay? In that shaded part, N2 and K2 and 3 is also the same. Okay? If I now look at this shaded part, oh, it's so small. Okay, this shaded area there and that part there. Okay, which angles are going to be the same? K1 and L2 and N3 and M3. Okay, let's see if I wrote this in. Yes, I did. K1 and L2 and N3 and M3. But also, I'm not going to look at theorem 5 there. And I apologize that on my little sketch that my drawn-in circle doesn't touch the edges. Okay, so I'm feeling very self-conscious about this. Okay, I'm feeling very self-conscious about that one. So basically, there we kind of go there. Now my circle looks wonky. Let me see. I've got a tool for circles. There we go. Okay, kind of looking like that. Okay, just makes my heart feel a bit better. Theorem 5. There's no theorem 5 I'm going to use because I don't have any values. But theorem 6 I'm going to use. If I look at my exterior angle N1, okay, N1 is equal to L1 and 2. Now I can also go towards M1, hashtag just saying. But I'm not going to worry much about this one now. Let's look at the next question. Question 2. Prove given reasons that triangle LKN is similar to triangle KSM. In blue, I'm going to now draw in my triangle LKN. So there we go. In green, I'm going to highlight that triangle KSM. Before I actually look at proving it, let's look at which angles do I need to have equal to which angles for the similarity to be true. So first of all, in triangle LKN, L must be the same as K. So in other words, L1 needs to be equal to K2. Because L and K stand first in the respective triangles. Secondly, K must be equal to S, but in the triangles, K is actually K, 1, 2, and 3 in the blue triangle, while for S is S2 in the green triangle. And I need to prove that N3 is equal to M3, again, blue and green. If I can prove these three pairs equal, then the triangles are similar. So looking at this, I'm going to start by the first things that I know. I know that M3 is N3 because angles in same segment. Okay, so that one is done. Remember, I colored those in with a green stars, or their x's. But next up, I'm going to try and stay away from K1, 2, and 3 because it kind of gets messy when you work with three angles in one. So I'm rather going to think about, maybe can I not get L1 equal to K2? So what do I know about L1? Well, L1 is M2. But M2 is equal to K2 because of alternate angles. So I'm going to do that. L1 is M2 because of angles in same segment. M2 is K2 because of alternate angles, and I mustn't forget my parallel lines. And therefore, L1 is equal to K2. Automatically, ladies and gents, K1, 2, and 3 is the same as S2 because of interior angles of a triangle. Remember, ladies and gents, you just need two pairs of angles that are equal, and the third pair will always be equal because of interior angles of a triangle. So let's finish off the sum. Therefore, triangle LKN is similar to triangle KSMY because of angle, angle, angle. Whew, this is a beautiful sum. See how we mix grade 11, grade 8, grade 11. I've got some grade 9 work proving angles or triangles similar. But now this leads me towards grade 12 work, because the moment that I have this similar triangles, automatically, ladies and gents, I write out which sides are in proportion to one another. Where are the equal ratios? First of all, LK and KS, because they're first and second, that must be equal to Kn and Sm because they are second and third. And lastly, first and third, so L and N and K and M. Those three pairs of ratios must be the same because they are similar. Which two of these am I going to use? Well, let's look at the information. I was given LK as being 12. In that second bit of information, they gave me Kn and Sm. So that's why I'm going to discard Lm over Km. But for me to actually get this, I need to kind of get into a ratio here for Kn over Sm. So I'm going to divide both sides by 3 and by Sm. Why do I do that? Again, look on the right-hand side. Your SMs cancel out. So I'm sitting with Kn over Sm being 4 over 3. This now, ladies and gents, I can substitute into that set of equations because remember, this is now my right-hand side. Okay? So once I've done that, I can substitute that LK is 12, and I'm going to solve KS. How do I do it? I first of all reciprocate both sides. I flip both sides to get the KS at the top. Then I'm multiplying by 12 on both sides, leaving me with KS being 9. You can solve it your own way, ladies and gents. If you want to cross multiply, I'm saying that in inverted commas, then you use it. That's fine. That's 100%. No problem at all. This is just a method that I love to use. Last and definitely not least is 11.2.4. Now for this, I'm going to write in the information that was given to me. So let me take it back a little bit, okay? First of all, they tell me that NL is 16, so I put that in my sketch. KL is 12, okay? Let me just make 100% sure. Is that KL, okay? Where does that come from? Remember, KL is 12. They gave it to me in 11.2.3, okay? Then they also tell me LS is 13, KN is 8, and they're asking me with reasons the length of LT. Now you might look at my sketch and say, so where on earth does the x's come from? Huh? Well, the x's come from, remember in the previous one we told you that Kn over Sm is 4 over 3. But that doesn't mean that Kn is 4 units long. It actually just says that's the ratio that exists between Kn and Sm. So for me to get actual values, I need to bring in a variable, 4x and 3x. I love to do that because then I can go to my sketch and I can write that 4x into there. And the beautiful thing is, by mixing the 2.3 and with this 2.4, I actually see there's a correlation. There is some overlapping that occurs, which means I can get x to be 2 by dividing on both sides. Why is that important? Because that means that Sm, which is 3x, Sm is 6. Why do I want to use this? Think about it. Have we used theorem 1 of your grade 12 work? We haven't touched it at all in this whole question paper. So because it's the last question, we know we're going to have to use it because they will ask it of you. So I'm going to look in the triangle. I'm just drawing the triangle separate from it. Okay? Let me go back there a little bit. So I'm drawing triangle LNM. So this triangle there, I'm just drawing it separate and filling in the information that was now given or calculated. So for me to actually use theorem 1, I'm going to say, well, LT over LN is the same as LS over LM. Why do I put LT at the top? Because that was asked of me. So LT over LN is LS over LM. And what's my reason? Line parallel to one side of the triangle. Next up, ladies and gents, I'm going to say times by 16 and times by 16. So LT is 10,95 units. Oh my goodness. I love this. I love this. This is so wonderful that we are mixing grade 11 and 12 work. You might not like it. You might not like it, but you're going to have to get used to it. My logic in this last sum, I knew I had to use theorem 1 because I haven't used it at all. And they gave me parallel lines, so why not use it? Ladies and gents, thank you for tuning in. I hope that you have learned much, about my approach to maths, and that you are going to give everything you've got in this time leading up to your final exams. So this is Mr. VG signing off. Please watch my other videos on the Junior Techie channel. There's a multitude of videos from not just myself, but from other math teachers as well. And we just want you to exceed your potential. So have an amazing rest of your day. Please give it all you've got. And I promise you, if you give it all you've got and you study hard, you can achieve your potential. You can achieve your potential. Now you might come and say, oh, sir, but before the exam, I know everything, but to get to the exam, I struggle. Then it might not be your preparation that's necessarily the problem. It might be the way you are handling stress. And for that, I encourage you to get as much help as you can. Talk to your parents, even talk to a psychiatrist or to a teacher or a mentor that have been through this, and ask them for ways that you can handle stress. So have a beautiful rest of your day. Cheers.